Hi, I'm Lauren White. In this lesson, we'll talk together about how to rank nucleophile strength by analyzing the electron density. So, what do we actually mean when we say that one nucleophile is stronger than another? Well, it means that that nucleophile reacts faster than a weaker nucleophile. So, anytime you see a strong nucleophile, you should be thinking that that reaction will occur pretty quickly as compared to that same reaction with another nucleophile. So one factor that we use to determine how strong a nucleophile is actually going to be is how are the electrons arranged? What's the concentration of electrons around that atom? And there are a few trends that you need to know here, and we'll dig into these in a little more detail. But the big idea here is that nucleophiles that have that big old negative charge sitting on them and are fully negative will always be better nucleophiles than something that only has a partial negative charge or a lone pair or even a pi bond. Another trend you want to know is that less electronegative atoms will be better nucleophiles. So think about some friends of yours. One of your friends loves sour candy and the other loves chocolate. And you have some extra chocolate candies and you give each of them a couple pieces. If you tried to ask your friends to give that chocolate back, you'd have a much harder time getting the chocolate back from the friend who loves chocolate. Your friend who likes sour candy will be like, meh, yeah, whatever, I'm not that big of a fan of chocolate. Electronegative atoms kind of follow the same idea. If an atom is very electronegative, it loves those electrons and it wants them all to itself. So it's a lot less likely to give those up. Finally, generally, having lots of electrons in one place, like an atom that has a full negative charge, is going to be a little unstable, and that's why this ends up being a better nucleophile. Unstable molecules are high energy, and so they're looking for a place to get rid of that energy, looking for a place to react. And so they react faster. And remember, faster nucleophiles are stronger nucleophiles. So let's do some examples. So this question is just asking us to identify which in each pair is a stronger nucleophile. So we have essentially the same general molecule here. Each of them has 1, 2, 3 carbons, and our carbon is bound to an oxygen in both cases. But what's the difference? Well, the one on the left is protonated, it still has a hydrogen, and the one on the right has a full negative charge. So we call this the acid, while it still has its proton, and the conjugate base of that acid once it's been deprotonated in a solution. Notice that the one on the left is still a nucleophile since oxygen has 2 lone pairs on it. However, like we said, full negative charges will always be a stronger nucleophile. So the stronger nucleophile here is the molecule on the right. Let's look at B. Here we have almost the same molecule again, but the one on the left has a nitrogen and the one on the right has an oxygen. Well, remember the trend in the periodic table for electronegativity tells us that atoms further to the right and the top of the table are more electronegative. So oxygen is going to be more electronegative. Is it going to want to give away its electrons? Not really. And nitrogen doesn't really want to either, but it's more willing than oxygen because it's just slightly less electronegative. So in this example, the molecule on the left is the stronger nucleophile. All right, one more example. Now here, we've got to think about multiple factors because our molecules here, we have oxygen and nitrogen again, but our oxygen in this case has a full negative charge. So we just said nitrogen will be a better nucleophile than oxygen, but what if we add a full negative charge to that oxygen? Oxygen with that negative charge is not happy. It's going to be looking for something to react with to get to a more stable situation. And so it will attack an electrophile much faster than the lone pair that's found on nitrogen. So despite oxygen being more electronegative, the molecule on the left is the stronger nucleophile. Now, you should feel more comfortable ranking nucleophile strength by considering the electron concentration around the nucleophilic atom.